Okay, let's get started. We're in the blood. And this slide shows you the blood's function. It carries nutrients, hormones, waste particles, gas molecules. And it transports cells, and that's the blood cells, and the compounds. These molecules are in your plasma. And the blood also helps to regulate body pH. The blood pH is about 7.4. And here it shows all the other functions of the blood. Regulate your body temperature. All the bloods, they are your body temperature. It's 98.7 Fahrenheit. The blood has blood cells and blood plasma. The plasma is the water part, mainly the water. And the blood cells part, you have 3 different kinds of blood cells: red, the white, and platelet. So in your blood, about 55% are plasma, and in the plasma is over 92% are water. And you have a small amount of plasma protein, and they can be divided into these 3. So let's look at this. Your blood, you have about 55% of plasma, and plasma, over 92% of plasma is water, and all the others, you have the other solute, ions, proteins, and the plasma proteins mainly divide into these 3. So about 60% albumin is the main one. Its function, transport lipids. So when we talk about steroid hormones, they are made of lipid. They won't be able to carry by water, so they need albumin to help them dissolve in water to be carried by blood. And globulin, that's the immune function. So when you got immune shot, that's this one. And the process to produce red blood cell is called the hemopoiesis. Now let's look at the cells. The cell part, you have about 45% of the blood is blood cell. And in the blood cell, over 99.9% red blood cell. You have plenty of them. And you are able to measure your blood, what percentage of your blood is blood cell. And the process is called hematocrit. So you take your blood sample and you put it into the centrifuge and you spin it for about 2 minutes. Then the heavy stuff of the blood will stay in the bottom and the light one stay above. And you just take a ruler, you measure the total distance, and you measure from here to here. Okay, say this is 4.5 centimeter and totally 10 centimeter. So you can do the math. So you found, okay, you have about 45% red blood cell. And we use this to identify, do you have anemia? Do you have more or less or normal red blood cell compared with total of them? In your blood cell part, about 45% are blood cell. And in the blood cell part, over 99.9% red blood cell. And the other, you have a little bit of white blood cell and platelet. The white blood cell, you have 5 different kinds of white blood cells. I memorize them as never let monkey eat banana. It tells you from the most abundant to the least abundant. Neutrophil, lymphocyte, monocyte, eosinophil, and basophil. And let's look at the function of red blood cell. They transport oxygen and CO2. And they live for about 120 days. When we talk about the bone, the red bone marrow, that's where those red blood cells being synthesized. And when they're getting old, your liver will get rid of them. And that's why you can donate your blood, because after 120 days, they will be recycled by your body. Your red blood cell looks like a donut shape. It gets rid of nucleus. So that's the cell with no nucleus. And this shape helps them to carry oxygen to the small capillary, through the small capillary, deliver oxygen to every body part. And the process to produce red blood cell called erythropoiesis is stimulated by a hormone called EPO, erythropoietin. And this is the hormone produced by your kidney when you are short of oxygen. And your body can produce this hormone. This hormone will go to the bone marrow as the red bone marrow produce more red blood cell. And that's the process. So your kidney and also your liver produce EPO when your body are short of oxygen. And this is the hormone carried by your blood will go to the red bone marrow and it will produce more red blood cell. And we all know this person, the Lance Armstrong, and he did blood doping. So he did blood doping is self-inject EPO, the hormone. And when you self-inject EPO, let's go back to the previous slides. It will produce more red blood cell. And you're gonna have more red blood cell to carry oxygen to his muscle. So that's blood doping. And blood doping is very difficult to identify through the normal urine test because his urine is clean. He did not take any medicine to enhance his muscle performance. What he did is increase his blood cell count, so he has more oxygen to his muscle. So that's the story of blood doping. Your white blood cell, it comes from a stem cell differentiated into different kind of white blood cell. I won't test you this part, so don't worry about this part. And this tells you have 5 different kind of white blood cell. Your blood type based on your red blood cell, and it's based on the antigen you find on the cell. So if you have antigen A, your blood type A. If you have antigen B, you have blood type B. If you have both, your blood type is AB. If you have none, and your blood type is O. And that's the old blood type. And in the late 20th century, we found another one called RH. 90% of us have RH. So if you have RH, if you also have A, so your blood type is A+. And if you have a B and RH, that's a B+. So that's your blood type. If you have antigen A, you're type A. If you have antigen B, you're type B. If you have both, you have type AB. If you have none, you have type O. And now let's look at antibody. Antibody is the protein you found in the plasma. If you're blood type A person, antibody will attack antigen. So if you're blood type A person, you could not have anti-A antibody because it will attack your red blood cell. So you can have anti-B antibody in your blood. And if you're type B person, you have anti-A antibody. If you're blood type AB, you could not have any, because if you have them, they will attack your red blood cell already, so you have none. And if you're blood type O, you can have anti-A and anti-B in your plasma. Because of that, when you receive blood, you need to receive the same kind of blood. So if you're blood type A person, you can receive A, and you can also receive O, because your anti-B won't attack O. So you can and that's why the blood type O is universal donor. They can give their blood to any one of them. If you're blood type AB, you can receive AB blood, of course. And in the emergency case, you can receive A, you can receive B, you can receive O, because you don't have any antibody to attack them. So AB person is universal receiver. If you're type O, you can only receive type O blood. You can give your blood to any other type, but you can only receive O because you have anti-A and anti-B antibody, and they will attack any other kind of blood. So you can only receive O. So O is universal donor. And if you receive different kind of blood, that's what's gonna happen. The antibody will attack the antigen, and it can cause the hemolysis, and it can damage the kidney, or the worst scenario, you may die. So this show you when you receive the wrong kind of blood, and the antibody will go to attack the antigen, cause hemolysis. Okay, let's take a short break.